Hey, so let's dig into Houdini a little bit, just learning a few basic nodes. We'll make some tiny planets, maybe Little Prince scale planets or a little bit bigger fantasy planets. So obviously we'd start with a sphere, and we'll dive down into that sphere, and we'll learn a very, very useful node called mountain. And mountain just distorts a geometry. Click the render tab and we see how that shape has been distorted, and we can see up here in the inspector we've got lots of controls like the height of the distortion, the element size, and time is actually going to give us different distortions. Time here really means variation. And then there's lots of different types of noise that we can experiment with. But one thing we want to do before we go too much further with this is this noise doesn't have the capability of very much detail because the mesh itself is coarse. So we're going to go back up to these rows and columns that we've seen before and crank those up. And now you can see we have a much, much greater possibility for variation in our mountain. And we can go down here and look at some of these. We're using Simplex Noise. This is sparse convolution noise, which is gives us an entirely different look, as opposed to flow noise, which gives us another look again. And so you can experiment with all those different types of noise. Now, what are we doing with this? Well, if we take this and mix it back together with our sphere using a merge node, and we render the merge node, we now have a planet that has landforms on it. And to see this more clearly, we can add a color. And see, if I hold a node over a cable, it'll insert itself. And I'll make the color blue. So now we can see we have the blue ocean and the gray landform. By the way, to move the object like this, I'm middle clicking in the window and dragging it around. And to zoom, I'm using the scroll wheel. And then to look at it from different angles, I'm left clicking and dragging. So you can play around with this and find the land that you like. Find the type of noise that you like. There, that looks pretty much like continents. I can really exaggerate them. Change the element size. I get some really giant mountains on this tiny planet. Just make adjustments until you're happy with your planet. Now let's take a look at what's happening here. We're taking a single sphere, we're coloring it blue, and merging it with a mountainous version of itself, a distorted version of itself. It would be exactly the same. If I hold down Y, I can click and drag and cut a cable. If I made another sphere and plugged it in to the color and added it back together with the merge, you can see now my two spheres have different numbers of rows and columns. My land sphere has high resolution. My ocean sphere has low. And of course I could change that if I wanted. And that's going to have some effect on how the land and the sea are rendered. But it's just as easy to use a single sphere and feed both processes, and then we're mixing them back together in the merge. But if we want to get this out to max, we have 2 more steps. I'm actually going to hold down Y, cut the merge out. I'm going to render my mountain. The 2 things I need to do are, firstly, I need to make a group. And I'll call this group land. And then I'll make another group here. And I'll call this group C. And this takes the entire geometry and places it in the group. There's my C group, which has the entire sphere in it. And there's my land group, which has the entire land in it. Why am I grouping it? I'm grouping it so that Max can tell the land and the sea apart when we import this. Then the other thing I need to do is I need to give it UVs. UVs tell the jit.gl.material that we're going to use in Max how to project the image onto the form. And that's a very easy thing to do. We can just say UV project. And now they have UVs. But we want to be able to see these UVs and evaluate them before we export into Max. So we can do a UV quick shade. And take a look at how an image is going to be stretched when it's put on top of this. And see, this is not ideal here, this wide stretching of the image. So we can go to the UV project and try a different type of projection, like a polar projection. That looks better. The image is still going to be distorted at the top, but the way in which it wraps around the world is pretty nice. Same thing here with the UV quick shade on our land. We have these big areas of distortion. We can choose a different way of wrapping the image in the UV project. We could try, for instance, a plastic wrap. And that's still going to create some pinched areas. Wow, that's pretty extremely distorted. Let's just try polar, just like the other one. Yeah, that's quite good. So this is showing us how the image is going to be projected onto the object. Then we merge. We can save geometry. Planet2.obj. Decide where we're going to save it. Go to my shortcut into my Houdini folder. Whoops, if I want to go back up a folder, I can click this double dot into my Houdini folder and save this as planet2.obj, accept. So now we can switch over into Max. So in Max, I've created a jit.world with a jit.gl.handle. I can take my planet2.obj, drag it into my project, and then from my project window, I can drag it into my patcher, and there's my world, and I can give it a material, and there's my world with a material. But what's the problem here? The problem is it's drawn all together. Well, because we set up 2 different groups in Houdini, I can use the draw group attribute to determine which group I want to draw. I'll draw group 1, and that's just my mountains. And if I option click and drag and duplicate this, I can draw group 2, and that's my ocean. I can do this. I can say at color 001, which is blue, no red, no green, all blue. And I can say at material mode 0. And now my ocean is blue. And I can make any other changes I want to the ocean. Like, for instance, changing the specular model to Cook Torrents. So I can have a different specular model on the water than on the land. And of course, if I want to keep that, I say transform changed attributes to arguments. And of course, I can add a full-blown texture to the land. Here's a cliff mountains albedo. Here's ambient occlusion. And here's a normal map. So now I've got some nice texture on my world. And of course, if I want these textures to load when my patch loads, I need a load bang. And then any other details I change, like for instance, if I change the specular model of the land, I'll need to transform changed attributes to arguments and resend the textures. And then this should save, close, and reopen, giving me all of my textures in place. So going back to Houdini, let's look at a couple other basic nodes. Saving this as planet 1. And I'll make a new planet here. Bring my sphere in. And let's say I want to put some cities on my sphere. Well, dive into my geometry node. I'm going to turn up my dim, my rows and columns. And I'm going to scatter some points onto my sphere. I'm going to scatter 300 points onto my sphere. So what this is doing is randomly placing dots, coordinates, on the surface of the sphere. And what I can do then is I can copy to points. So I can take another shape, for instance, a box, and I can copy that box to every point. Now the box is quite big, so this is going to create something that doesn't look like much at the moment. But if I turn down the scale of these boxes, we see, I've copied a box to every point that I scattered onto my sphere. And then if we bring back our friendly merge node, now I can see the boxes on my sphere. So this is the beginning of a planet with a city on it. So what could I do here? Well, I could concentrate my buildings on one area of the globe. So to start with, I'm going to hold down Y, cut these chords here, move this aside, and I'm going to show another use of the group node. We've seen the group node separate sections of a model so that we can apply different textures to it. In this case, I'm going to use the group node to select part of an object so that I only scatter points onto that part of the object. So I'm going to insert my group node here between the sphere and the scatter. And right now it's selecting the whole sphere. And I'm going to say keep in bounding regions, which creates this blue box. So this becomes the selection box. Anything within this box will join group 1. So if I move the selection box up, then only the top half of the sphere is selected. I've moved the center up by 0.5 meter. If I move it up quite high, like to 0.9, only the very top of the sphere is selected. So I'll call this group top. So now in my scatter, I can choose to selectively scatter my points onto a specific group. I'll choose top. And now when I go to scatter, all my points are just scattered onto the area specified by group top. So now when I copy the points, all of my cubes appear at the top of the sphere. So when I put my merge node back in place, merging the sphere itself and the copied points, I have these buildings on the top of my world. Now, that's not a very interesting city because all the buildings are the same size, so we'll just look at one more thing. So once I have my points, here are my scattered points, I can add an attribute to them. And an attribute that we might want to change here is scale, because we want the boxes to be different size. So I'll say attribute create. And I'll create the attribute scale. Now, here's the thing that is a little bit challenging. Scale is a 3-dimensional attribute. It's got width, height, and depth. So it's not of type float. It's of type vector. Vector is a way of saying a series of related numbers, or a set of numbers. Okay, and then I can randomize that attribute. Randomize scale. So now, when I copy the points, all of my buildings are different sizes. And when I merge it, it's looking, well, it's not like a city, it's more like a town. But if I started my box taller, all of my buildings change proportionally. I could start my building very tall. Now it's looking more like a city, but it's still got the quality of randomness. So same as before, we're going to use the group node twice. To separate our city call this group planet. I can insert a node by clicking on a cable. Call this group city. City and planet, separate groups. And also, we need to create those UVs again. So for the planet, I'll insert the node. UV project. And we liked the look of a polar projection last time. We don't need to put in the UV quick shade because we know how the image is going to be projected onto the sphere, but we can, if we want, just to make sure. That's how. Okay. And for the buildings, while I could project the UV onto this completed city structure, really the easier thing to do is just to project the UVs onto the box itself. So I'll add a UV project and a UV quick shade just to see what effect this has. And it projects onto the box. Now, in this case, we're getting some strange distortions on the top and bottom of the box. And no matter what we do, we're not really going to get a good result. So instead of UV project, we're going to try a different UV object to get the UVs onto the box. We're going to try the UV Unwrap. And that actually does a very nice job of placing the texture onto the box. UV Unwrap is an alternative to UV project that doesn't cause those same problems with the texture. So we've got our groups, we've got our UVs, we've got our finished planet. So we can again save geometry, and we'll call this planet 3. Accept, and we can take it back into Max and see how it fares. Now, if you do what I'm doing, if you do a save as in your project, you also need to add that existing file to the project. So now it appears in the project. So I'm going to add Planet 3 to my project and just change this to Planet 3. And you can see I've got my draw, it looks pretty good, but I've got my draw groups backwards. But I'll just keep it this way. I like the blue city on top. Who says it has to be an ocean planet? So there's two fantasy planets made in Houdini and imported into Max.